So with the conclusion of chapters 4 and 5 on exponential functions and logarithms, we actually finished an entire unit, right? So we finished our entire second unit for the year, which now brings us to unit 3, which is all about the wonderful wide world of trigonometry. So before we can get to trigonometry as you know it, we need to sort of establish a baseline here, all right? And trigonometry, right, triangles, measuring, all right, before we can get to all of that, we need to establish some conventions about how we measure angles. And we are going to measure all of these angles in the context of something that we call a unit circle, okay? And eventually we will get to the point to discuss why are we putting these on a circle. But for right now, I think we're just going to get the mechanics down because guess what? It's not too difficult. So the first thing we need to know is, what is a unit circle? A unit circle, by definition, is a circle with a radius of 1. So we're going to write that in, and then we'll put some labels on our picture beneath. And that makes sense, right? Unit circle, circle with radius of 1 unit. Okay, so if we come down to our picture here, if this is to be our unit circle, all right, we know that the radius is 1, so we can kind of, infer that this distance here, from here to here, is a length of 1. So we know the coordinates of this point right here. All right, if this, right, that's a radius, right? This is also a radius, right? All of these lines from the origin to the edge of our circle are a radius, right? So all of these have a length of 1. So if we know that, we can start to assign some coordinates to these points on the circle. So for example, this point right here would be the point 1, 0. We've gone right 1, up none. This would be the point 0, 1. This would be negative 1, 0. And this would be 0, negative 1. I know, this is a far cry from what we were doing before with logs and exponentials. All right, but here's our unit circle. All right, so I'm just going to erase these things because we're going to be marking this up pretty significantly in just a moment. All right, so again, we have to define just a few basic conventions that we use. And why do we decide to do things a particular way? Because we had to pick. We could have chosen another way, but this is the way that we picked. It's like PEMDAS, right? PEMDAS could have been MEDPAS or anything, but we had to pick. All right, so whenever we measure angles, we measure from what we call standard position. So standard position means that we start on the x-axis on the positive side. So we'll say, whoops, pencil. Starting on the positive side of the x-axis. Okay, so if I were to measure out an angle of, let's say, 30 degrees, all right, well, that means I have to start in standard position, which basically means start right here, right? See how that is the positive side of the x-axis right on the x-axis. So if I were then to measure out an angle of 30 degrees, that might be roughly here-ish. And when we draw these, we're not going to like bust out the protractor, and be super precise. But like qualitatively, we should be approximately correct. All right. So a couple things happened here, right? So we started in standard position, all right, and we rotated this way. So this way right here to open up to an angle of 30 degrees. So that's an important thing to note. All right, if I tell you that we rotate 30 degrees, I mean 30 degrees in the counterclockwise direction. So that's actually what's going to go in this line of text right above our picture. When measuring angles, we rotate in the counterclockwise direction. Why? Because we had to pick. Okay, so start in standard position and then basically move up in this case. Now, sometimes if you're measuring a lot of angles on the unit circle, it can get a little crowded around the origin where you are labeling all these angles. So we will tend to do this, put a point on the unit circle, right, where we've drawn our angle, and label this as 30 degrees. But ultimately, all right, the hope is that we recognize that that really means that this angle in here is actually 30 degrees. That's what that really means. So let me just show you, another one just to get our bearings. So if I were going to measure out an angle of, let's say, 70 degrees, all right, well, I would start from standard position, right, and then rotate counterclockwise 70 degrees, so up 70 degrees. All right, so maybe this rotation here was a 70 degree rotation, and so we would mark that with a 70 degrees up here. That's typically what we do, but really we know that that means that that interior angle is 70 degrees. So what I would like to go ahead and do right now is mark some of the more obvious points on our unit circle. So standard position, all right, this angle right here, basically starting in standard position and opening up none, that would be an angle of 0 degrees. All right, if we rotate from standard position all the way up to our y-axis, that is a rotation of a full 90 degrees because that's the right angle. So this is 90 degrees. Okay. If we start from standard position and rotate all the way to the other side of the x-axis, so right here, that's 180. And if we start from standard position and rotate all the way down to here, so this angle right here, that's going to be 270, right? Because that's just so many instances of 90 degrees, all right? And if we start from standard position and rotate all the way around, one full rotation around the circle, hopefully we remember from geometry that that's a full 360 degrees. So this point here at 0 degrees, right, if we're there and we have rotated none, that could be 0 degrees, or if we've done one full rotation, it could also be 360 degrees. So while we're at it, let's just go ahead and fill this in here. One full rotation around the unit circle is 360 degrees. Okay, so let's see where we are. All right, I think at this point, I'm gonna clean up my picture a little bit, just so that I can mark it up a little bit more with some new examples, okay? All right, and we're just gonna practice measuring out some angles. But I wanna leave I call them our 90 degree reference marks, 0, 90, 180, 270, because they're gonna help us to position some other angles. All right, so let's measure out an angle of 65 degrees. All right, so 65 degrees is less than 90, but more than 0. All right, so that's gonna put us somewhere right here. All right, so this is a 65 degree rotation, so we'll put 65 degrees right here. All right, let's measure out a 140 degree rotation. So starting from angle 0 and rotating 140 degrees, Well, 140 is more than 90, but not any more than 180. So that's probably going to land us, maybe here-ish, right? If we start from standard position and rotate 140 degrees. So this is the time when I would like to introduce the concept of the reference angle. Okay, a reference angle simply means the angle that our angle makes with the x-axis. All right, so let's go back to this 65-degree angle here, right? This one right here. Its reference angle is pretty obvious, right? What angle does this angle, let me get my highlighter, does this angle make with the x-axis? Well, that's pretty clear, right? The reference angle is 65 degrees. So I'm going to say reference angle is 65 degrees. Okay? But it's not going to be so obvious when we get to our 140 degree angle. Because when we drew our 140 degree angle, right, we started from standard position and rotated 140 degrees counterclockwise. And that brought us right there. But then we asked the question, what is the reference angle? Which means, what is the angle between our angle and the x-axis? So reference angle is always relative to the x-axis. And hopefully, you can maybe take a minute and think about how you would figure that out, right? Basically, what is this measurement right in there? That's going to be your reference angle between your angle and the x-axis, right? Well, we could say, I know that the x-axis is 180 and my angle is 140. So in other words, I am 40 degrees away from 180. I am 40 degrees away from the x-axis. Therefore, my reference angle is 40 degrees. Okay, so let's just go back right now and make a few notes about reference angle. So reference angle, by definition, is the angle a given angle makes with the x-axis. Okay, so important things. It's always the x-axis. Always, always, always. All right, and as such, all right, your reference angle is always going to be acute. So a reference angle is always an acute angle, right, which basically means that it is less than, I guess, or equal to, it technically could be 90 degrees. For right now, I'm just going to say less than 90 degrees, okay? So a reference angle is always acute. So the reference angle cannot be like 100 degrees. It needs to be less than 90, okay? And just to clarify, the case when your reference angle would be exactly 90 degrees would be a case like this, when you've measured out an angle of, say, 90 degrees. So you're here, and the angle between your angle and the x-axis, no matter which way you draw it, is 90 degrees, okay? All right, so let's do a few more reference angles, maybe in some other quadrants, and get some practice. All right, so let's measure out an angle of, let's see, let's do 260 degrees. So 260 degrees, that's almost 270. So I'm going to show that I start in standard position and rotate almost all the way to 270. Again, your picture doesn't need to be perfect. All right, and I'm going to label this as 260 degrees. Now, it's very tempting for some people to say that the reference angle is 10 because, 260 is 10 away from 270, but that would be measuring our reference angle relative to the y-axis, and that just ain't how it's done. All right, so to answer the question, right, what is the reference angle? I'm going to be looking between my angle and the x-axis. Now you might ask, how do I know to draw that angle and not this one? Because here and here, well, that's also, right? This right here is also an angle between my angle and the x-axis, but guess what? That's not acute. All right, so hopefully that can help you make an informed decision. So our reference angle is going to be the angle between my angle and the closer side of the x-axis. So the reference angle is right here. And so then, again, we might do a little bit of arithmetic here. Say my angle is 260. I know that the x-axis is at 180. Oh, so 260 minus 180. Oh, okay, that's going to be 80 degrees. So the reference angle is 80 degrees. Okay, we are going to do one more and then we'll move on from this. All right, so let's see. Let's measure out an angle of 320 degrees. Okay, so 320 degrees, that's going to be more than 270, but not quite 360. All right, so I'm going to start in standard position and rotate maybe about here-ish, okay? So 320 degrees. Okay, so then the question becomes, what is my reference angle? Well, that's going to be the angle between what I just drew and the closest x-axis. So that's going to be right in here. And I can now, again, just do some basic arithmetic and say, hey, my angle's 320. I know that the x-axis up here, that would be a full 360, right? So there is a difference of 40 degrees. Therefore, my reference angle here is 40 degrees. Okay, so I think that should take us through all of the basics on this page, and then the rest is just going to be some practice and establishing a few conventions or taking a look at a few weird cases. So when you're ready, next page. Okay, so on this page, we basically just put into practice what we did before. I would recommend that you maybe have your calculator. The math is not necessarily difficult, but addition and subtraction, that is not where we want to get bogged down. All right, so this is like your level 1 sort of, can we put this into practice? All right, and I would like, as best you can, for the work that you do to model the way that I do it, just because we want everything to be super clear to the reader. Okay, so the instructions are to draw each angle in standard position. Then we're going to identify which quadrant, all right, our angle has landed in. All right, and let's just refresh our memory that we start, right, in quadrant 1, 2, 3, 4. So that's kind of nice, the idea that standard position and how we rotate agrees with the quadrants, right? Start here, move counterclockwise. So at least we're consistent in our choices here. Okay, so you can put that on the previous page. In fact, I would recommend doing that if you have any room left on that page. Okay, so an angle of 100 degrees. All right, well, 100 degrees is just more than 90. All right, so maybe I will put that here-ish. Okay, and I would like you to show that you started in standard position and rotated counterclockwise, at least for now. All right, so we will mark this with a 100 degrees. All right, this has landed us in which quadrant, right? Well, quadrant 2, so I'm just gonna put quadrant 2. all right, next to it. All right, and then we want to identify the reference angle. Well, remember, all right, reference angle is going to be between our angle and the closest x-axis. So it will probably be helpful for us to remember that this point right here is 180 degrees, which will make measuring this distance much easier. Oh, what's the difference between 180 and 100? Well, that would be 80. So your reference angle is 80 degrees. Done. Okay. So then next we have an angle of 265 degrees, which is actually not that different from one we did just on the prior page. 265 degrees is almost 270 degrees, right? So 270 degrees would be all the way down here, and 265 is going to get us almost there, but not quite. All right, so here's maybe 265. And I'm going to show that I started from standard position and rotated all that way around. Okay, and so that lands us in quadrant 3. And so now to figure out the reference angle, I'm going to figure out the angle between my angle and the closest x-axis. So again, I'll probably want to label this as 180 to make it easy to do my math, because then figuring out the reference angle is figuring out this distance right here. In other words, how far away is 265 from 180? And that would be 85 degrees. And last but not least, 340. All right, well, 340 degrees, that is almost 360, right? So going all the way around would bring us around a full 360 degrees. So we're gonna go almost all the way around and maybe stop here-ish. And we'll mark that as 340 degrees, and that puts us in quadrant 4. Okay, so now to figure out the reference angle, we're going to figure out the angle that our angle makes with the x-axis. It has to be acute. So that's this angle right here, and it will probably be helpful for us to remember that if we had gone all the way around, it would be a full 360. So that's basically like asking, what's the difference between 360 and 340? Well, that would be 20. So here, your reference angle is 20 degrees. You're probably starting to get the hang of this. So your job is to go ahead, all right, pause this video and do 4 through 9. If you feel like you're getting the hang of it and want to move on, that's fine, but you will have to finish these for homework at some point. Otherwise, I will see you on the next page. So hopefully the exercises on the last page went smoothly for you. You're starting to get the hang of it, get comfortable with the basics, and you know the way it goes in math. You start feeling confident, you get the basics down, and then we're going to throw you a curveball. But honestly, it's not that bad. All right, I would just like to direct your attention right up here. All right, angles whose measures exceed 360, right? So if an angle measures more than 360, all it means is that we've gone around more than once. It's not that big of a deal, right? I could just keep rotating, and technically that would be a rotation that was more than 360 degrees because I went around more than one time. All right, so hold off on the other stuff for now. We will come back to that. All right, I just want to show you, I want to start with an example, okay? So I'm actually going to go to number 11, and then we'll come back and define all of this stuff. All right, so, all right, we're basically going to draw each of these angles, and then, again, I'll let you know what all of that, symbology means. So, 400 degrees. All right, so 400 degrees, that is larger than 360. So clearly, I've gone around one full time, right? So that gets me to 360 degrees. And then how much extra did I go? Well, let's see. 400 minus 360. You can't see this, but I'm doing this on my calculator. All right. Oh, so 400 degrees is 360 plus an extra 40. Okay, so I went the full 360. That's this right here. So that was the full 360. And then this bit was an extra 40 degrees. So here's 400. All right, and we've actually just already done a few things that were asked for in the instructions, right? Right here, we basically just figured out the reference angle, right? We figured out what is the distance from here to my x-axis, right? 40 degrees, all right? We've also figured out what quadrant we've landed in, right? We have landed in quadrant 1, okay? But then we have also identified a coterminal angle that's within one rotation of the unit circle. All right, so let's talk about that. All right, a coterminal angle. Coterminal angle just means they're angles that lay right on top of each other. You wouldn't be able to tell the difference between them. All right, so coterminal angles are, right, so an angle that lands in the same exact spot as another angle. Okay, so for example, in number 11, an angle that would be coterminal with 400 degrees would be just plain old 40. Right? If I just started in standard position, rotated 40 degrees, I would land right on top of my 400 degrees. So I'm going to say that 40 degrees is coterminal with 400 degrees, right? In the case of 40 degrees, I just rotated a little bit. In the case of 400 degrees, I rotated all the way around and then some, but ultimately I landed in the same spot. Thus, 40 degrees and 400 degrees are coterminal. So, what this means when it says identify a coterminal, whoops, that was not what I wanted. I wanted the highlighter. Identify a coterminal angle theta such that, theta is between 0 and 360, it just means identify a coterminal angle that is bigger than 0 but less than 360, right? 400 was more than 360. So this is just saying find me a coterminal angle with 400 that's less than 360. Okay? Now let's talk about the theta because that might be raising some questions. Theta, whoops, now I want my pen. All right, theta, it's just a variable. It's like an x or a t or a y or whatever, all right? But we tend to use Greek letters when we measure angles, and theta is a Greek letter. So I sort of make them like this. They're very easy to make, and we pronounce it theta. So basically, anytime you see a theta, you could think about it as an x, right? Just identify me some angle, right, so that it's between 0 and 360. That's all that it's saying. Okay, so let's take a look at example 12, and we're going to do all the things again for number 12. So we've been given an angle of 535 degrees. Obviously, I've gone around more than once. So I'm going to say, alrighty, I went around a full 360, right? So that sort of lands me at 360 degrees right here. But then how much further did I go? Well, let's see, 535 minus 360. How much do I still have left to rotate? That's going to be 175. Okay, so I need to continue to rotate an additional 175 degrees. So that's almost a full 180. So here's my additional 175 degrees. Almost to 180. There we go. So I'm going to mark this as 535 degrees. I have landed in quadrant 2. All right. And before I can identify the reference angle, I should probably figure out what angle between 0 and 360 am I coterminal with. In other words, going around one full time and then, going around a full 535 degrees is equivalent to just starting in standard position and rotating a plain old 175 degrees. So 175 is coterminal with 535 degrees. And then it becomes a little easier to answer the question, what is the reference angle, right? Because again, reference angle is going to be between my angle and the x-axis. I know that the x-axis is 180, and it is much easier to figure out the reference angle with your smaller angle, right, the 175, rather than the 535. Because if we know that 535 and 175 are in the same spot, it becomes a little bit more obvious that your reference angle is 5 degrees. Okay, so take a moment, let all that sink in. I know it's a little bit of arithmetic, but again, all we're doing is spinning. We're just rotating. Okay, because then we can sort of get ready for the boss fight on this page, 927 degrees. Okay, so 927 degrees, very obviously more than 360. So let me go around a full 360. So here's 360. And let me see. So if I start with 927 degrees, I've gone around a full 360. So that leaves me with 567 degrees to go. Oh, so I've got to go around another time. So let me go around another time. So that means I've gone around another 360. So minus 360, 207. Okay, so that's gonna leave me with 207 degrees that I still have to complete. So I went around 2 full times and then an additional 207 degrees. And 207 is going to land me a little bit past 180. So maybe about here. So I'm going to mark this as 927 degrees. But I also know that going around 927 degrees was basically the same as starting in standard position and just going 207 degrees. So 207 degrees is coterminal with 927, right? And of course, all of this has landed me in quadrant 3. And then let's figure out the reference angle. And again, it's always going to be easier to figure out your reference angle with your smaller angle. So I'm going to work with the 207, not the 927. All right, so reference angle will be, right, what is this minus my 180, the distance between my angle and the x-axis. So that's just going to be 207 minus 180, which is 27. So here, my reference angle is 27 degrees. Okay, so we're putting in a little bit of math. You can go around more than once, but hopefully it's not that bad. All right, take a stab at some of the practice here. And again, just remember all the things that you're trying to do. So first, it's draw the angle in standard position. Show me how many times you rotate, okay? Then tell me what quadrant you land in. Find me a coterminal angle that is, between 0 and 360, and then tell me what the reference angle is. So put this video on pause, work on yours, and then I'll see you on the next page. Okay, and last but not least, there's just like one more little wrench we can throw in the works here, and that's the idea of a negative angle, right? A negative, pretty much in like math, physics, anything, it's really just gonna mean that you go the opposite direction. So if a positive angle tells us to start in standard position and rotate counterclockwise, a negative angle tells us to start in standard position and go clockwise, right? So up here, right, it just tells us we move in the opposite direction, and all that's going to mean is that we start in standard position and move clockwise. It's really not too bad, in my opinion. Okay, so if we take a look at some of the examples here, all right, let's start with negative 30 degrees. So that means we're going to start in standard position, but instead of rotating up 30 degrees, we're just going to move down 30 degrees. So we're going to go to here. We just go down 30 degrees. And this is negative 30 degrees. That's it. All right, but we still want to do all the things. All right, so we have drawn the angle in standard position. We have landed ourselves in quadrant 4. What do you think the reference angle is? Right? What is the angle between our angle and the x-axis? Hopefully you can identify that as 30 degrees, right? It's pretty easy for this one. So I would say that the reference angle is 30 degrees, okay? And then our job becomes to take care of this part. Find an angle that is coterminal with negative 30 that is between 0 and 360, because guess what? Negative 30 is not between 0 and 360. Negative 30 is negative. All right, so we basically want to answer the question, going backward 30 is the same as going forward how much? Oh, well, that's going to be as simple as doing start at 360, go backward 30. Oh, 330 degrees. Okay, so going backward 30 degrees will land you in the same spot, right? Will be coterminal with a positive 300 degrees, okay? And that's kind of nice, that if you have a positive angle and a negative angle that are coterminal, they should always add up to 360. So that's a nice little trick. Not too bad. Okay, so number 18. Negative 100 degrees. All right, so that means that we are starting in standard position and going backwards 100 degrees. So we have to go back more than 90. We have to go back 100. So we have to nudge ourselves just past 90. So maybe that's here, minus 100 degrees. Okay, so we have landed ourselves in quadrant 3. And then, let's see, in this case, I think figuring out the reference angle is going to be easier if we find our normal coterminal angle first. So we have to think, all right, going backwards 100 degrees is the same as going forward how much? Well, again, that little trick really comes in handy, right? 360 minus 100, 260, right? Because notice, right, that this little bit that I drew here, right, this makes a full circle, right? So it should add up to 360. All right, so going backward 100 is the same as going forward 260 degrees. So that's our coterminal angle between 0 and 360. And so then we just have to answer the question, what's the reference angle? And I recommend working with the 260, not the negative 100. right? Because it's going to be easier to measure that 260 against the 180. And then we say, oh, okay, our reference angle right in here, oh, that's going to be 80 degrees. Just 260 minus 180. Okay, one more example. Negative 312 degrees. Okay, so negative 312 degrees, that is rotating backward quite a bit. In fact, we've maybe almost rotated backward a full circle. Not quite. So I'm going to start in standard position and move backward 312 degrees. And as you do these, you'll start to get a sense for, you know, more precisely where you should land. But I will mark this as negative 312 degrees. We have landed ourselves in quadrant 1. And so then we have to ask the question, all right, rotating backward 312 degrees is the same as rotating forward how much? Well, let's see. 360 and a negative 312 is going to leave us with, 48. So rotating backward 312 degrees is the same as rotating forward 48 degrees. And reference angles, if you're in quadrant 1, are very easy, right? What is the angle between 48 degrees and the x-axis? Why, that would be 48 degrees. So if you're in quadrant 1, your reference angle is the angle itself, as long as it's positive, okay? So just remember, reference angles, they're always acute and they're always positive. Okay, so if you've got those concepts under control, you should be good to go ahead and do some of the practice here. It's sort of, some of these combine some ideas together, but you guys are bright. I think you'll be okay. Just make sure that you finish up this entire activity over the weekend, and I'll see you not on Monday, on Tuesday, I guess. Have a good one.